So, I am Dr. G.K. Singh. I was the director of AIMS Patna. I am basically an orthopedic surgeon, and therefore, research is as difficult or new to me as to most of you. Now, we are talking of study designs. So, let us first of all talk about ourselves. All of us are conscious beings, and we are all the time trying to be aware of or control the event around ourselves. So basically, the events have to be classified as good or bad or neutral. Using our own previous experience of the event, either stored in our memory or using somebody else's memory, which we call learning from somebody else's mistake. So, if we are using somebody else's memory, this is the concept of education. We don't have to commit the same mistake. So, basically, what we are doing, we are learning to ignore the neutral. This is called as habituation. And we want to react correctly to the painful or pleasurable. And this may have to be done in a time critical manner when that is called as an emergency. Basically, our consciousness awareness is so designed that it ignores the neutral events. They can never reach the consciousness, and this is called as habituation. Sometimes the event is so time critical that we have to react without the perception reaching the consciousness. That is called as reflex. And what we are doing for ourselves from birth to death is what we may have the responsibility of doing for the others, for the community. So that becomes the individual perspective to community perspective. So let us give you a example of how people decide for the community or the individual. So here is a situation. We have a very large number of patients in which this middle cerebral artery supplying half of the brain gets a clot in between, gets a clot here, so that half of the brain can't function and you develop hemiplegia. This is also called as hemiplegia or stroke. So, a surgeon in Saskatchewan district of Canada put this other artery distal to the clotted clot so that the circulation was restored. So, this was the clot, it was stopping the circulation. We put an artery which restored the circulation. So this is called as bypassing the clot. You also do it in the heart attack. So this should help. Here the concept is that this should help. By your knowledge of the structure and the function, this should help. And this is called as biological plausibility. And this is simply a decision based on the rational understanding of the mechanism of the problem. So the operation which was developed in Saskatchewan district of Canada took over, and thousands of people were operated. Till one student in the conference questioned the conclusion. Should help, but did it help? For that help, for that answer, for that help, yes or no, you have to find out the proportion or the ratio of helped and not helped in the operated and the not operated. So this is the type of table that you develop. Operated, yes or no, cured, helped or cured, yes or no. So supposing we artificially fill in these numbers and we say that 30 were not helped in the operated group and 5 out of 100 were not helped in the unoperated group. So this chance of not improving is 5% in the unoperated group but 30% in the operated group. So the operation was actually, bad results were 6 times more in the operated patients, and therefore the operation was discontinued. The New England Journal of Medicine writes that the trial comparing the two treatment options, conservative and operative, was a costly one. It took $11 million to complete. But by merely randomizing half the patients to conservative or non-operative, $27 million were saved. Therefore, the evidence that has to be believed is not should help. It should be did help. So the did help doctrine has to replace the biological plausibility or should help, and this is called as data-based evidence. So your understanding, 10th class you said bye-bye to mathematics, and therefore that divorce has to be reversed, and your understanding of the language of numbers should make you good users and producers of data-based evidence by doing good research and by being able to use good research. All research is based on the art of measurement. And what are you trying to measure? You are trying to measure events of interest that you have classified as good or bad, either for the individual or for the community. And then you have to understand what caused this, and all the measures of these events of interest must draw a conclusion which is correct and credible. So, correct measurement, correct analysis would yield correct and credible evidence which can be relied upon to make decisions for individuals or for the community. But you must understand that you can do research on anything. But research is a resource using activity. For example, if you would have put half the patients to the operative and half to the conservative, the operative one suffered because you gave them the wrong treatment, the harmful treatment. So, all research, all comparisons on populations are costly in terms of cost to the patient, cost to the nation, and cost to intangible costs or risks to the subjects of research. So, since it is a resource using activity, therefore, it always revolves around events of interest. So, if your research or your answer has not been answered before and is able to go large good to large numbers, then that research is most likely to be funded. So let us imagine an event of interest. Let us go back to Wuhan, China, where unusually large numbers are reporting to hospital with fever, respiratory problems, and some of them are becoming hypoxic and are dying. Now, given the situation, as a leader of the situation, you can be a person in Wuhan, you can be an in charge doctor, you can be a health administrator, you can be the Prime Minister of China, or you can be the WHO. So, each one will have to do something, will have to perceive something, and then will have to do something so that the people there is maximum good to maximum numbers. So for this we repeat our definition of epidemiology. Epidemiology is an unusually high number of adverse events at a given place in a given time, and when this happens, it can be called an epidemic or a pandemic. And epidemiology is a study of the distribution and determinants of this event of interest. Here it is a negative event which was called as COVID. So what does distribution mean? Distribution means when, where, who suffered. Time, place and person distribution of an event. And then you have to define why. So the studies that describe the time, place and person distribution are called as descriptive studies. And the studies which try to define why are cause-effect studies. Cause-effect studies or causality studies or analytical studies. So, the first thing is to define what is exactly happening. And for COVID, for example, for COVID, you can clinically say fever. So you will catch a large number of people who are not COVID. So that will be called as false positive. then you can say person with fever and respiratory problem. Then your false positive will decrease. And if you say testing positive for the antigen of COVID, this false positive will further decrease. And if you say COVID virus demonstrated in the respiratory tract of the person, then there is very little chance that you are false positive. Therefore, you have to take a measurement which will have very, very few false positive and false negative rates. So less false negative is equal to sensitivity of a test. And less false positive is called as the specificity of the test. And the test that has 100% sensitivity and specificity, that means zero false positive and false negative rate, is called as the gold standard, or as much near as that as possible. So you may want to have the simplest test. For example, they chose this antigen test. This antigen test was available in the market, and you could test the blood and see whether the antigen to COVID, whether the antibody to COVID existed in the blood of the patient or not. So this antibody test was chosen to say whether a person has COVID or not. This culture was difficult, so culture was not used so often. Now this test, since it is simpler, less costly, is called as surrogate. It is simpler, it is less costly, it can be done over large numbers. So initially what they started doing was that they started testing by the gold standard, demonstrating the virus for all the people that were coming from China or from anywhere else. Because till then the spread was from outside. Then when the epidemic reached the second stage, then the spread was from inside to inside also. So they said, okay, we'll develop this antibody test, which is not the gold standard, and they had to, supposing this is the antibody test, positive or negative, gold standard positive or negative. The sensitivity was 70 upon 110. That means the test was able to catch 70 out of 110 people. False positive rate was 40. Then specificity was 60 upon 90, because these are the true positive and the true negative squares. And these are the false positive and false negative squares. So you develop a table like this, and if you want to use a surrogate, then you have to validate the surrogate against the gold standard. So after precisely defining what, you have to conduct a study on the population. Since you cannot study the whole population of 130 crore Indians, you study a sample. And the sample that you take, for example, if this is the whole population, you don't take a sample here. You should be able to take a sample here. And the only way to sample correctly is to have a sample of appropriate sample size and to be able to randomly select, so that the results that you get from the sample are applicable to the others in the population. So this could be done, this was being done by two ways. One, measure all, and say this many are diseased, this many are diseased. So the proportion diseased, let us say 2% were diseased, 2 out of 100 were diseased. So this is the value in your sample, and you assume that 2 out of 10,000 population will also be diseased. So this is called a statistic, and that is called as parameter. It's called as statistics, and that is called as parameter. So to increase your confidence that this statistic will estimate the parameter, you can say that 1 to 5% were diseased. Now you converted this point estimate into an interval estimate, and that interval estimate is more likely to include the truth or the parameter. So this interval estimate is called as confidence interval. As the estimate goes on increasing, for example, you can say 0.5 to 7. Now the interval has increased. So as the interval goes on increasing, your confidence that it will include the parameter goes on increasing. And if you are 95% confidence that the interval estimate will include the parameter, it is called as 95% confidence interval. So one way of estimating a problem, specifically a chronic problem like diabetes or hypertension, not COVID, is to do a survey. But here we were not able to do a survey. So we do a surveillance. So here these are our hospitals, and we are measuring how many are coming in 1 month in these 3 areas, in 3 hospitals, totaling them N1 plus N2 plus N3 and dividing it by time in which they came. So you are getting a rate of reporting to a hospital. And usually it is supposed that for every case reporting to the hospital, you may have 1,000 in the community. For example, only 20% of the COVID reported to the hospital. Then that means that for every 20 cases that reported in the hospital, you had 80 in the population that did not report, or they were asymptomatic. So they were contributing to spread of the virus, but they were not visible. So that is the concept of surveillance. Data from all places collecting at one place, and you are finding out what is happening over time. Is the problem increasing or is the problem decreasing? Okay. So you have applied a gold standard or a good surrogate to the population, and you have been able to get data over this whole population. So you may have done many studies here, and the mean of the results of each of them is assumed to be the mean of the universe. So this is called as the central limit theorem. Now, I told you that if you want your sample to represent the universe, so that the results in the sample are the same as the results in the universe, Then you have to do random sampling over sufficient sample size. And you have to know how to calculate sample size. So we have covered this much. We've covered this parameter and the concept of a narrower interval having less chance of hitting the or including the parameter than a wider confidence interval. So one measure of the central tendency of the numbers that you get is called a standard deviation, and 2 times standard deviation has 95% chance of including the parameter. 3 times standard deviation has 99% chance of including the truth or the parameter in the universe. So all these surveys will only describe the time, place and percent distribution of the event of interest, and thus they are called as descriptive studies, only describing one event. Now comes the question of why did it occur? Because you have to modify the why to be able to control the effect. So you have to modify the cause to control the effect. So here there are two events of interest, cause and effect. Here you divide the study population, supposed to be representative of the source of the target population, on these two variables, cause and effect. And so you have a table like this, cause present. Let us say we were talking of COVID. So does traveling, air traveling, increase the chances of infection by COVID? So we take travelers, 100 travelers, and we take 100 people who have not traveled in the last month, and we find that 8 out of these 100 had COVID, were COVID positive, and only 2 out of the 100 who did not travel were COVID positive. So we analyze this table like this. We say 8 upon 100 is the risk of COVID given travel, and 2 upon 100 is the risk of COVID given no travel. And therefore, because of the travel, there is 4 times higher risk of COVID as compared to those people who did not travel. This number is called as relative risk. Also by that you can say that 6 more, 8 minus 2, COVID positive occurred in 100 tested if there is a history of travel positive. So travel, 6 more per 100 are attributable to travel. If you ban the travel, you will say 6% of COVID. All this is called as univariate analysis, and there are 2 ways to develop these tables, to put these numbers. One is you take travel positive, travel negative individuals, follow the cohort, this is called as cohort, forward in time, and find out how many got COVID, how many got COVID positive and how many got COVID negative. So what proportion got COVID amongst travelers or not? So here you are basically measuring this in this cohort. It is a forward going cohort study. This study is called as prospective or a forward going cohort study. But the other way to populate these numbers is that you take a population, find out who had divide it into 2, COVID positive and COVID negative. For example, if this many were COVID positive, and then you classify them into travel history positive and travel history negative. So this is a backward going study. The exposure has already occurred. So it is called as a retrospective study. Now if another way to do this study is that you take COVID positive and for each case of COVID positive, you take COVID negative. So in this study population, the proportion of COVID positive and COVID negative is 50. You have artificially controlled the prevalence of COVID in your study population. So this population is no longer representative of this. This is called as cross-sectional, but this will be called as case control study. The problem with the case control study is that you have artificially fixed as 50% or 25% the affect positives in a population. So another way is that you want to find out whether drug A or B causes a higher cure rate in COVID patients. So it is a cohort study, you will give drug A or not, or drug B to the patients. Here you are controlling the exposure, and therefore this is called as experimental study. If you randomly allocate to drug A or B, the study is called as a randomized control trial. But if the exposure is not in your control, for example, smoking or non-smoking, for example, traveling or not traveling, then it is called as an observational study. So these are the study designs, and this is what I wanted to talk to you about.